Hello, and thank you for taking the time to join me here today. Last night I had the opportunity to present at the Python user group here in Edmonton, Alberta. But one of the things I didn't have an opportunity to do was get a recording of that presentation. And a few people have asked me to share my presentation. They didn't have an opportunity to come out for the meetup, which was a great time. There was a lot of creative energy going on and just great conversations, and I hope that everyone can meet up in the coming months. But I wanted to take this opportunity to maybe share a little bit of what I had to say last night to share with you today. So what my hope is that somebody is early on in their learning journey with data science, and they're looking for ways to better understand their trajectory through all of this introductory material. Learning Python, if that's your programming language of choice, it was for me, and also learning some of the mathematics and statistics, diving into machine learning. All of these things can be very daunting, and there's a lot of information out there and a lot of different resources. So this is the journey that worked for me. I was successful in becoming confident with my data science understandings, and maybe this will work for you as well, or maybe just little bits and resources along the way. So my name is Cody Schellenberger, and for the last 6 years I've lived in Saudi Arabia, in the capital city of Riyadh. And my family worked at the American International School in Riyadh. And for over those 6 years, I worked as a science teacher for grades 9 and 10. I also worked as the high school technology teacher. And for the last 3 years at the school, I was the assistant director of technology. And that's kind of where my love for data started, and where the majority of my very first data projects came to be. The first data project, and maybe the largest even, wasn't even related to the school. It was related to the compound where we lived. And this is an image of that compound. And the data project arose from the fact that within each one of these villas is an automatic tracking system for utilities. The compound, though, didn't have a great reporting system, and they didn't hire somebody to aggregate that data in a meaningful way and report that back to the residents. So I took it upon myself to track my own utilities. I actually took webcams and put them into the roof of my villa and started to capture readings at the same time every day for 3 months. And I aggregated my own water, electricity, and air conditioning data and created my own dashboard. What I found is that even though the reporting process was poor, the actual prices that they were charging us were very accurate. So I took that back to the school, and they had me work with the compound to kind of generalize the data for the teachers. They allowed me to query the database every month, and then I generated a dashboard that the teachers could log into and then see their daily usage and modify their utilities usage as they saw fit. The second big data project I worked on was related to the admissions at the school. So we took historical data over the last 30 years, and we found trends in terms of when students would state that they were coming to the school, when would we gain the tuition payments from those students, and also looking at attrition, when those students would normally leave the school and give in their notice. And we found some good trends, and we were able to hire teachers more accurately and also project budgets more accurately and more timely. It was a very successful project for the school. And then I wanted to continue my data projects. So I looked at various platforms, and at the time I was looking to change careers out of education. And Springboard has a great mentorship aspect to their program. So I was one-on-one with a data science mentor, and that was weekly. And then I also had the opportunity to be one-on-one with a career coach at my request. Springboard, I would say, in terms of their curriculum, is kind of this great curator. They've generated a learning path that works for data scientists getting into the field, and they found all of these available resources online. Harvard is used for the very technical aspects of machine learning and the mathematics that supports those algorithms, and it's all taken from the publicly available CS 109 courses online. Khan Academy was used primarily for mathematics and statistics learning, and then they had a strong partnership with DataCamp. And actually, if you log in to DataCamp and you subscribe to their service, the career track that DataCamp provides for Python in data science is very similar. You end up doing the whole track within DataCamp. But when I dove into my first few DataCamp courses, I knew that it wasn't going to work for my learning style. I already had some experience with other platforms like this. Coursera I had done before. I did Codecademy courses before, and I found them very routine. I would arrive at an exercise like this, and I'd have my exercise, I'd have the instructions that are normally very detailed, and then you have your code structure and the console where you can investigate your data sets and kind of play around with everything that's available in this online learning environment. But if you take your instructions as puzzle pieces and you take the code structure that they've given you as a puzzle that's 75% or 80% already done, you can get quite good at just plugging in the puzzle pieces and working through these things routinely. And the more you do, yes, it'll start to sink in terms of this, routine that you're going through, and it'll become, a memory structure for you. But I wanted to dive deeper. I wanted to make sure that the learning I was doing within these courses was going to emulate the learning I was going to do as a data scientist. So at the beginning of each one of these courses, I generated a Jupyter notebook. And at the head of that Jupyter notebook, I made sure that I detailed the learning objectives for that course. I made sure that the links for all of the documentation of the packages were in there. I made sure that all of that stuff was just fanned out in front of me right off the bat, so that I would be able to pick and choose the different documentation pieces and learning resources that I would require for this course. And then I worked hard to make sure that I had the raw version of the data that they used in whatever exercise or task they were asking me to do. So here is the actual data set from that DataCamp exercise that I had shown in the previous slide. And it's housing prices, and we're building a regression model that's supposed to predict those housing prices with XGBoost. And so here I build a data frame called housing, and I use pandas to read in the CSV, and then I inspect the head, so the first 5 records of that data frame. Then I look at the column list. So I call the columns method on X, which is the features in DataCamp using their console. And then I investigate the length of that list, and I find it to be 56. So there's 56 features that they're going to train this XGBoost model on to try to predict these housing prices. If I inspect the length of the housing data frame in my Jupyter notebook from the raw data, it's only 21. And one of those is the target variable, the actual housing prices. So I only have 20 features to train on. So now I have a conflict. Now I'm starting this learning process of saying, okay, I have this discrepancy. How am I going to rectify that? If I look at these columns from the console, the ones at the top here, I can see that the categorical variables are broken apart. Let's say if I'm learning data science, I might not have the terminology that you learn later on in your journey with this, right? I can see that the zoning, right? I have the 1, 2, 3, I have 4 different zones there. All the neighborhoods are also at different categorical levels. This isn't a complete list, right? It's cut off. Not all 56 features are shown. But there's something to do with the categorical variables here. So I might go onto Google and I might start searching. Okay, how do I break apart categorical variables in a pandas data frame? And you might stumble across a Stack Overflow feed, right? And that thread will probably lead you somewhere that encodes categorical variables. Maybe you'll land on pandas get dummies. Maybe you'll land in sklearn and start learning about one-hot encoding. But trial and error shows that they probably used pandas, right? And they probably used get dummies in this scenario. And if you were to grab that solution online and dump it into your Jupyter notebook, you might not know the syntax, right? I would recommend jumping over to pandas and looking at their documentation for that function, for that get dummies call. But if you're in Jupyter notebook, I use this all the time. You just land your cursor right between the parentheses of your function and you hit Shift Tab on a Mac. And you're going to get the signature and you're going to get the doc string. And that'll help you to master the syntax for that particular function. So here I can see that I can pass my data frame into get dummies and that'll get me started. So that's what I do. I create a new data frame called housing encode, which is going to encode my categorical variables. And I pass in housing to get dummies. Then I inspect the head again and see what I have. Now when I check the length of my encoded data frame, I've gone too far. Now I have 62 features, one of them being my target variable, so 61. So what did I do? If I look at the columns list and I bring that in, so I grab it from the console in DataCamp and paste it into my Jupyter notebook as a list, I convert that to a set. So if you know your data types in Python, if I convert them to sets, I can use set theory and the mathematics that backs that to figure out which of those category or those features are different in those two lists. So I run that difference method on there, and I see that there's one categorical variable. There's one level of each of those categories that's been removed. One building type, one house style, one zone, one neighborhood, and the Boolean paved drive, there's only the yes, not the no. And then there's sale price, my target variable. So what I forgot to do is drop the first level of each one of those categorical variables. My machine learning algorithm is intelligent enough to ascertain if it's not one of the, let's say, 13 neighborhoods, it must be the 14th or the one I left out. And mathematically, it's going to perform just as well. So getDummies has a keyword argument called drop first. So I pass true to that keyword argument and I check the length again. Well, actually, if I run the difference, now I only have my target variable. So I'm ready. I can generate my own feature set now, X, just like in DataCamp. I drop the target variable from the housing and code data frame, and I can generate my own target variable Y by pulling that pandas series out, the sale price variable. And now the length is matching. I have 56, just like in DataCamp. And when I look at this exercise again, now I have so much more background. I know where that feature set came from. I know where that target variable came from. I'm starting the learning process to understand why this training and test set is required. I know how many features I'm training on. I know how many samples I'm training on. And I'm so much further ahead than what if I would have just jumped into and started plugging in the instructions into the code base. So then I had all of these IPython notebooks, and I wanted some way to catalog them in a meaningful way that I could share them, I could look back on them for reference, and GitHub was the perfect solution. I created a repository called Data Science Learning, and I started to embed all of those IPython notebooks in that repository. I made sure that the README file was easy enough for myself to interpret. So on the left-hand side there, I had the learning sequence chronological. I had the titles of each one of the courses that I had engaged with. I had links to my IPython notebooks, or if they weren't code-based, if they were more technical, I would just generate a markdown file for those. And then the notes were detailed enough that if I were to go back to this README file and I was starting, let's say, a new unsupervised learning task, I could easily find which one of those courses dealt with that topic, and I could click on it and then get up to speed on my introductory information for that particular topic. What I wish I would have done more of is used GitHub's gist function, or gist feature. And you're able to pull starter code out of your courses, out of your learning, and dump them into these gists. And they become very easy to share online and recall afterwards. So I have ones for pandas to set up the configuration. That's the one shown here. I have ones for matplotlib to set up the view configuration before I start a visualization problem, and a bunch of other ones. And I keep thinking of new ways to kind of catalog these code starters. And then I wanted to extend. I had finished, roughly a dozen of these DataCamp courses, and I wanted to extend my learning beyond that platform. So I was put onto these resources by a few community members and my mentor. HackerRank was great at honing my native Python skills and also my SQL skills, which are important, very important SQL skills for a data scientist in training. And Kaggle was great at the beginning because you'd get all of these introductory topics completed, and then Kaggle would have these nice, clean, ready-to-go data sets that you could then test those algorithms on, or those wrangling techniques on. And then Stack Overflow obviously became a great friend early on, but what I tried not to do was take those solutions at face value and just take them from Stack Overflow and dump them right into my Jupyter notebooks. I tried hard to make sure that I was diving into the documentation for the solutions and figuring out what's the full extent of get dummies, right? What is possible to do with that function. And that led to a lot of good learning. And reading documentation is something that you should get good at early on. And the more you practice it, the easier it's going to be to start digesting new new tools in data science as they arise. And then I was on to my first project. So my wife and I, we were looking for a house in Edmonton at the time. So it was very relevant to me looking up the property assessment values in Edmonton, and they're publicly available through the city's open data project. So I pulled that data set. I also pulled the crime from that calendar year, and I pulled the latest census data for population. And I started investigating and started to build a tool that residents could use to understand the neighborhoods that they were living in, and maybe, assess a neighborhood that they potentially want to live in. So here's a plot that I made early on in that project. It's a empirical cumulative distribution function, and it just shows this classic distribution of wealth, right? You got your assessment values on the bottom there ranging from 0 to 10 million, and you can see that about 2% of the housing values are over $1 million, and the rest of the 98% of housing values are below. And then there's these light blue triangles that show percentiles of property assessment values. I won't get too much into the code that I used to generate this, but you can see that I run a stats function Python file at the beginning. It incorporates a few functions that I wrote from a stats course that I did. And then I plot all of those property assessment values utilizing that ECDF function. And I plot the percentiles using NumPy's percentile function there. Here's another plot that I generated in that project, and it just shows the population versus the crime for each neighborhood in Edmonton. And it's layered, so on the first layer there's matplotlib scatter plot, and that puts the dots in their appropriate coordinate spots for population and crime. And then there's another layer for the annotations, so kind of pulling out a few of the outliers in the data set and then coloring them as such. So downtown, Central McDougall, you got Boyle Street and McCarley. They are neighborhoods that seem to have slightly higher criminal incident rates for their population size. And then Summerside is an example of a neighborhood that seems to have lower than average criminal activity for their population size. So here's the code used to generate that. Right off the bat, we're pulling out two series, Panda series, the population and the number of criminal incidents, setting the figure size, and then plotting the scatter plot using pyplot from matplotlib. And then there's setting up the annotations. Now, this is very manual. I actually pulled these values directly out of the data set, and when I went to update it a couple days ago for the 2019 data, those quite obviously broke. So if you check the GitHub for that project, these are all now programmatically generated. They're not just raw values pulled out of the data set. And then there's the Seaborn regression plot, and that builds that linear regression line and gives you those shaded error ranges, which are really nice. And then there's labeling of the axes, and there's a call there to save the figure to my local memory, and then to show the plot to the console there. One of the last things I did with this project was to take the latitude and longitude data that was supplied in the Edmonton Open Data project, and I used Folium, which is a Python wrapper for Leaflet, and Leaflet is a JavaScript library for interactive maps on mobile devices. The nice thing about Folium is that the syntax is fairly easy, and once you've generated your map, it's fully interactive. Zooming in and out, hover, um, click, everything is interactive. So my function allows you to pass your neighborhood in Edmonton to the function, and the first call there to the Folium package is using the map function, and that centralizes to the neighborhood that you passed to the function. So it takes the mean latitude, the mean longitude, and it sets a zoom level, which I just had to play with until I got it right. Then I start generating the markers. So I wanted a spectrum of colors. If you have a low assessment value, you have a dark blue. If you have a very high assessment value, it is dark red. And I just pulled the hex codes for those colors and built that spectrum using if statements. Then I generated the tooltip. So when you hover over any of those circle markers, you're going to see the address for that property and the property assessment value. Then I generate those markers with Circle Maker from Folium, and then I add them and apply them to the map, and then I return the map M2, which was instantiated further up above. And that's what I have for today, and that's what I was able to present at the Python meetup. What I will say is that github.com there, that is my GitHub profile, and you'll find the data science learning repository there. You'll find the Edmonton Capstone project, which is the property assessments. It's been updated for 2019, and you can find through those links in the README file, you can find all of the data sets required to get that project running on your own machine and playing around with it. There's my LinkedIn if you want to follow me on LinkedIn or ask any questions about those projects or data science learning in general. And that's my email if you want to talk about data science. Thanks again for joining me today, and hopefully we can do more of these in the future.